All right, we're going to talk about APIs. In today's study group, I'm going to go over the New York Times API, which I believe one of your labs does talk about. And then after that, hopefully we have some time and we'll talk about the TMDB API wrapper, and I'll explain what that is in a little bit, but that will probably help with your projects. So to start, what is an API? APIs are short for Application Programming Interfaces, very important for the modern internet. APIs are basically what allows everything on the internet to play nicely with each other and work together. One example that I like to use, here you can see that I have an example in like Pokemon Go, if anyone remembers that like phone app game. Pokemon Go is basically you can like walk around and catch Pokemon on the street. So with, sorry, I lost my train of thought. Okay, so imagine Pokemon Go, you have a map. And imagine if you had to store the map on the app itself. If we had to store the map of, I guess, the world on the Pokemon Go app itself, it would take up a lot of memory, right? Imagine how much Google Map has. And if anyone's played the game, like it basically goes down into detail of like your, what is it, like your 10-meter vicinity, I think. So having to store that information locally on an app can be very, very memory intensive. Instead, what Pokemon Go probably does is they actually use an API where they can continually grab information using your location, grabbing the map's information. So instead of having to store the entire map of the world on the app, instead they can just query an API and continually update what the map looks like on your screen. So that's an example of an app that uses an API. Probably they're using an API to store like your user information, because you want as little information be stored on the app itself. It just makes it a lot more efficient. But that's also why the internet connection is extremely important in a lot of things now. Okay, so what is an API made up of? In our example of doing API, we'll actually encounter a bunch of these. APIs have access permissions, whether you're allowed to ask for the data or services, a request, and a response. So request is basically what you're asking for. Pokemon Go's example, you're giving them the current location of GPS, using GPS, and you're just asking for, the map of wherever I'm at. Within the request, you have methods and parameters. In every API's documentation, it does tell you what methods and parameters are available. And then response. Response is the data that we get in return based on our request. So we're going to look at these in a little bit. But right now, we're going to talk about the New York Times API. This might look kind of familiar because we had New York Times JSON back in like topic 3. But let's take a look at this API. So New York Times is actually a great resource. If you want to look at this for your future projects, they actually have a bunch of APIs that they keep updated. There's like article search, books, bestsellers list. But the one we're going to talk about is the movie reviews API. So movie reviews API, basically you're allowed to query this API and get information about movie reviews. So you can see you can search New York Times movie reviews by keyword and opening date and filter by critics picks. I'll walk through this later. And what we're going to do is figure out how to use this API. Typically on most API documentation, they give you some examples. And I like to start from the examples. So here, they actually give you an example call here. Great. We're going to copy and paste this to save for later. Okay. So when you're making a request from an API, there are a couple ways to do this. But whenever we're getting data from any other part of the internet, the Python library requests is what is most popularly used. So we're going to import requests real quick. And then this is actually copy and pasted. This is the exact same URL that we had before. Let's see what happens. The way that we use requests, whenever we're trying to get information, we're going to do request.get. We're actually going to see this come back tomorrow when we talk about web scraping as well. So request.get, throw in that URL and let's see what happens. Cool. Let's see if we can get any text out of that. Actually, first, let's take a look at the response. Cool. We get a response 401. Interesting. If anyone's seen like 404, error 404, not found, something like that, these are actually all universal codes. So let's take a look at see what 401 means. Wikipedia is a good resource for this. And we have 401. And 401 basically says unauthorized. So it's basically saying that we're not authorized to get information out of New York Times. Cool. Most APIs are like this. You usually need to get some sort of API key or password to access their data. Good for us. Let's see, I have a lot of tabs here. The movie reviews or New York Times, you can actually get an API key instantaneously when you make an account. I'm going to sign in really quickly. I already have an account. Wait, is that the email that I use? Let's see. Oops, hold on, give me a second. Sorry, guys, I have like a bunch of different passwords. There we go. All right, so for New York Times specifically, the way that it works, they want you to create an app first and then tie the API key to an app. So if you go into here, click on apps, you can create a new app. I already have one that's created. And they usually tell you to like just give it a name. What it is doesn't really matter. It automatically generates an ID, but then you have these API keys that are given to you. And this was automatically generated when I created this new app. So cool. Let's copy and paste this API key. So 401 was unauthorized. Let's try it again. But at the end of this, let's add my API key. So I'll talk about what that is in a little bit, but I'm going to paste my API key here. Cool. So at the end of this URL, you can sort of figure out what it's doing. Let me find a better version of this here. Oops, where was I? Here we go. Okay, so within this example call, you can see that you have a /review/search.json. We're querying for Godfather, and the API key is equal to your key. So just by guessing, I'm going to replace your key with my API key that was automatically generated. So I did that, and I do enter. Let me do response real quick. Cool. Now our response code has changed to be a 200. Awesome. So let's take a look and see what 200 is. 200 is okay. Awesome. So our API call was successful. Now, how do we take a look and see what our request is, what our response is? It does depend. Most of the time, APIs come in JSON format. So this is something that honestly you can trial and error. But let's just do response.json. When I did response.json, you can see that we actually have some data. What I did was I queried for Godfather, and what came back was, I guess, some results on movies that matched the search query Godfather. So here you can see I have the Black Godfather here, Godfathers of Ganja, so on and so forth. So we have some information. Awesome. Another way to do it, if it isn't in JSON, you can also explore .text is one as well. Of course, it turns the entire thing into a string. So for this, in this case, not the preferred format, most recent JSONs, recent APIs, and by recent, I mean like in the past 10 years, do come in a JSON file format. All right, and once we have this, pretty cool. All we have to do is parse through the dictionary and figure out where the information lies. Because I've seen this a bunch of times before, I know that the information lies under results, because you can see this is just status, copyright, blah, blah, blah. You're going to use the same exploring tactics that you use to just explore a large dictionary. I know it's all in results. And then I know that my results are in here. And then I can maybe even look at the first one to see what we have. So cool, just like this, I have information. Now to circle back, let's talk about API keys and what we need to do with them. So on your Jupyter notebook, the idea is you should not have your API key directly visible. Imagine that this is a project that I'm working on, and if I were to push this up to GitHub, there's a way for people to get basically my password to access New York Times data. And it's always fair to assume that if people have your secret passwords, they're not going to do great things with it. There are also some measures put in place by some companies that run APIs that will actually scan the scan the internet and scan GitHub for your password, and they might actually strike against you if they find your password publicly available. So we basically have to find out how can we hide this. So this brings us to our next part, where I'm going to walk you through creating what is called a config file. In your labs, it actually goes through a different way of doing this. I personally like doing the config file. If you want to follow the curriculum's way of doing it, which is basically creating a one-stop shop folder on your computer to store all your passwords, you can follow that, but I'm going to show you all a way to do it, I think, quickly. So let's do that. So what we're going to do is we're going to create a brand new file. So wherever your repo is, and this is where my repo is, I'm just going to create a new, oops, not a notebook, a new text file. And what I'm going to do is call it config.py. It's going to be a Python file, and it's typically called config. So we're going to rename it config.py. And Jupyter automatically recognizes once you change the extension to .py, it automatically recognizes that it's a Python file. We're going to get more into Python files next phase, so don't worry about this too much. But this is pretty much somewhere that you can write Python code. And all we're going to do is we're going to save our API key as a variable. So I'm going to call it NYT key equals to, actually, no, I'm going to call it ish key. Oh, wait, yeah, let's call it NYT key, just in case we talk about the other API later on. And we're going to also save it as a, save it as a string. Awesome. We're going to save this and then go back into our notebook. So we know that I actually do not want to see, oh, I hate that it's not big enough. We do not want to see my API key at the end here. So instead of that, what I'm going to do is I'm going to turn this into an F string where I can impute my API key. So I'm going to call this, I think I call it ish key later on. Let me just double check real quick. Okay, ish underscore key. I just want everything to be consistent. And I'm going to call that ish underscore key. And what I'm going to do here, how I can get this to interact with this here, I'm going to do from config import ish key. Let's see what has happened here. What did I name it? Oh, NYT key. That's right. NYT key. Cool. So this has been imported from my config file, just like that. If I output NYT key, it actually stores my string. So that is one quick way to get around having your actual password visible on your notebook, which is not what you want to do. So just like this, we're gonna just change the variable into key equals NYT key. Great. And so now when this runs, it is again a response 200. So we've basically done the same thing, just that instead of having our API key visible there, we just have it as a variable. Now, you might ask, okay, well, this config.py file, if we push it up to GitHub, won't this be there as well? Depends. Well, one pretty typical thing to do, and actually what I already had you all do when setting up your projects, is in your git ignore, and let's just look at a random GitHub. So in your git ignore, oh, this is another same thing, but in GitHub, most well-structured repositories have a git ignore. And if you remember from last time, what we talked about when we were setting up the project, the git ignore basically tells it what files to not push up to GitHub. So if I just go in and add config.py at the end of my git ignore, which I had you all do already, and if you haven't, just go ahead and add it later on, then you'll be fine. Your passwords will not get pushed onto GitHub. Any questions about the passwords? Okay, awesome. Next, let's talk about this URL. Let's break down this URL a little bit more because it's going to be very useful to know for when you're exploring different APIs. So let's close this. We don't need that anymore. All right. So every documentation page, as you probably know by now, is structured a little bit differently. For New York Times specifically, I did spend a good amount of time exploring all of your documentation just to figure out how it's structured to begin with. But it gives you a bunch of different paths. And in paths, it shows you what kind of information you can retrieve. So here it sort of implies that you can search for critic information. So I guess stuff about the critic themselves, or stuff about the reviews. And here we're going to use the reviews. Either you already know what specific kind of review you want to do, or we can just use a general search function, which in this case, this is what we're going to do. You are usually given a base URL. And more specifically, this is not a URL, it's a URI, which stands for Uniform Resource Identifier. I think I have a little bit around here somewhere. Cool. Yeah, it's called a URI, Uniform Resource Identifier. And so usually how it's structured is you have this base URI, and then what you do to filter and edit what kind of information you get from an API, you just add different query parameters. So you can see here we have query parameters here. We have critics pick, whether it's critics pick, and it even tells you what values are allowed. So we'll add a critics pick equal to Y to the end of this if we want a critics pick or not. You have a bunch of others. I'll talk about offset in a little bit. Let's say we want to look at opening date. And so let's just say for this purpose, we want to look at the opening dates, or we want to look at movies that were released this year in 2021. And for opening date, they even give you the format in which you want to see the date. So you can see here it's year, month, day. You can assume separated by a colon if you want start and end date. All right, so a bunch of different parameters, and here you can see we had this earlier for when we did the Godfather, query equal to string. And so the way that you structure this, you can actually have as many parameters as you want. And the way that you structure it here is after search.json, you add a question mark, and then just do your parameters like so. So here I'm doing opening date equal whatever. If I want to do critics pick, and by the way, I did this last year, so let's do this. If I want to do critics pick, let's double check on what the parameter is called, critics dash pick equal to Y. If we do critics dash pick equal to Y, and you separate your parameters with an ampersand, with an and sign. And then as you can see at the very end of this, I add API key equal to. I'm just doing that so that's easier to add my API key at the very end. So here you can see when I do my request.get, I'm using this URI, which I've defined here, opening date 2021, and then critics pick is yes. And then I'm going to add my key at the very, very end, and then take this as a JSON. Oops, I have to run this first. Awesome. Why is this not working? Oh, let's see what happens here. The results, cool. Problem with opening date. Let's see what's wrong here. All right, let's just give it an end date of 2021, and today is 06/03. Cool. All right, so now we have our information. So these are basically movie reviews from movies that were released in 2021 that are also critics pick. Awesome. So once you have something like this, it's really a time to just explore the data that you've received. Again, what I like to do is I like to look at the results. So results, you can go into results here. I know that's where the key is. It's a list. Cool. Let's find out how long this list is. The list is 20. All right, 20 movies, not too bad. We can look at the first one first. We have There Is No Evil, opening date. We have the headline. We have URL for the review as well. Date this was updated, so on and so forth. If you want to do it really quickly, we can even look at what keys they have. Oops, I'm going to do the first one. And there we go. And then just really quickly, if I want to throw this into a data frame, let's import our pandas, and we have our results just like that. So just like that, of course, you might want to do some cleaning later on, but just like that, we have 20 movie reviews. Cool. Any questions at this point? All right. So 20 reviews, great. This is information that we got just by pressing Shift Enter once. What if you wanted more, right? Like very likely if you are doing a project, you want to have more than 20 data points. So how do we do that? Combination of two concepts, pagination and offset. So pagination is the idea of putting result sets together, and offset is just offsetting your results. The idea here is we have this offset parameter that we talked about, and most APIs have this offset parameter. Here you can see that it takes in an integer, must be a multiple of 20, defaults to 0, and then they have this has more field that indicates the response has more results. Cool. Let's explore this a little bit more. So here we have, and let's change this date one more time. I think they might have updated it since 0603. All right, so the first time we ran this, we had the movies There Is No Evil up to Truffle Hunters. And when we rerun this now, you can see that our first result was Spring Blossom. And all I did was add offset equal to 20. So what this does, it basically starts at result number 21 and continues on. They did specify that in this API specifically, the offset parameter only takes in a multiple of 20. So keep that in mind, especially if you're using this specific API. So I guess let's just try with a different number. If I do offset equal to 40, nice, it's a different movie again. So the idea here is we just need to do this over and over again with different multiples of 20 and put them together. And so how can you do this? With a function or in a loop. For this purpose, I wrote a kind of clunky function, but whatever, kind of clunky function that edits the URI for offset. So you can see here, because I know that it takes in a number that has to be a multiple of 20, I get the number of reviews that I want. Here I'm using floor division. So basically, if I put the number 99, it's only going to give me 80 results. It's going to round down to the closest multiple of 20 just in case. And what we're going to do here is we're going to impute this offset here. I use a dot format. You can do an F string. It really doesn't matter. And I have my API key as well. And this is going to do, okay, let me copy over the dates again, just so it's consistent. We have this date and we have this date. Okay. So what this is doing is, for some reason, the default wasn't working when I set up this function. So if it isn't 0, I'm going to start here. And if it is not 0, it's going to loop through the by 20. So here it's going to be n times 20. There we go. Because I'm doing the floor division here, do n times 20 again. I think I'm going to do I times 20 for this one. Okay. So what we're doing here is I am just looping through the numbers 0, 20, 40, 60. And hopefully this works. Cool. Not 4. Now we want to do 100. Just as an example. Cool. So just like that, and let's double check. We should have 100 movies. Perfect. Just like this, we have 100 movie reviews. And then what you want to do with this information, you got to clean it up, set it to date time, clean the strings if you want, so on and so forth. But just like that, we have 100 movies, 100 movie reviews from the New York Times. This function is definitely going to change based on what API you're using. All right. At this point, any questions before we move on to talking about the TMDB? All right, so for this project, I did tell you all that you are welcome to get your own data. Again, you really don't have to. This is just up to you if you want to try out APIs. So TMDB is pretty neat. They actually do have an API, and I want to talk about this later, the documentation specifically. And on TMDB, if you just sign up for an account using their API, I think you go to like getting started. Wait, hold on, let's go back. If you go on to getting started, if it will load, if you go to getting started, it'll tell you, it'll basically give you instructions on how to get an API key. I did this like last year, I think, and I basically found that this person sent me an API key here. So great, I have an API key. Awesome. Something that's pretty neat that will make your life even easier is that a lot of very popular APIs, especially if it's like a big company or if it's an API that just a lot of people end up using, and it's very worthwhile searching up if an API does have one of these, is oftentimes people will create Python wrappers of APIs. So instead of having to, set up these URIs all the time, which as you can see can get pretty tedious over time, instead of having to set up these URIs all the time, some people have created Python wrappers for APIs, which basically are Python libraries that in the backend do the API call for you. And TMDB is an example of one of the APIs that does have a Python wrapper, which I'm going to show you how to use. So down here, the wrapper is called TMDB simple. If you just look it up, you can actually pip install TMDB simple, and it basically, through methods and functions, helps you access the TMDB API, I think a little bit easier. So with the TMDB API, and I think I saw this earlier, all you have to do is import it and then give it your API key. So I did that down here, imported that. And when you are doing this, please use the config file. I'm just doing this really quickly for demonstration purposes. Once I run this, it sets that this is my API key. It just needs to store that information somewhere so that it can query the TMDB API. So this is the example that they actually have on their site. Basically, if you want to do a TMDB movie search, you just have to start with a search object. Whenever you do something like this, where it's not really doing anything, this is called instantiation. We'll get more into this in, I think, phase 3, so don't worry about this for now. But basically, you have to give it like a search functionality. And then from that search functionality, you can do .movie and give it a query. And so this I literally just copied and pasted. And I just edited this to just show the results. So if I'm searching for any movie with The Bourne, you'll see these are my search results. And each search result, and actually if I show you search.results, oh, and by the way, it comes from search, but it can also come from response, I believe. So response is here. And then within results, we can look at results. Cool, we have a list of dictionaries, awesome. As usual, we can also check for the length of this. We have 6 results of The Bourne. And then just for the sake of looking at it more easily, we can throw this into a data frame. Cool. So just like this, we have our results of the different Bourne movies. So this is the search functionality. The way it's structured, this wrapper specifically, it has you actually reference the API documentation of TMDB. So that's why I have this open here. Let me close out this, and let's go back to here. So let's just say for this project, you just want to get a bunch of different movies, and it doesn't really matter. You don't want to give it a search query. I mean, you can, you do have like titles of movies that you can do search queries on. So you could potentially loop through that or something. But looking at the side here, there's a discover option. The one that I was talking about before, there's a search option. So you can either do search.company. So here you see how we did search.movie. Here we could have done search.company. We could have done search.movies, which is what we did here, search.movie, search.tv to get us like different TV shows. And just to show that it works, let's do search.tv and let's look for, I wonder if The Bourne has any TV shows. Oh, I guess it does have one from like 1988. Cool. So that's just how it's structured. Not every API wrapper works the same, just a big disclaimer, but just to make this easier for y'all to navigate. So from here, let's take a look at Discover. So basically from Discover, you can see over here, hopefully it's big enough. There's Movie Discover and then TV Discover. For this project, we're going to do movies. So the way that this is structured, this is basically for their URI, what their URI will work. But because you're using a Python wrapper, you have to kind of figure out like the hierarchy of things. So literally just by trial and error, I tried instantiating a discover functionality, and that happened to run. And then therefore, I could do discover.movie. And for the queries or the different, for the query parameters, you actually feed them in as arguments to the .movie method. So really interesting. This just really quickly showed me like all the movies from 2021. I can run that again. And actually, let me just do a pd.data frame of this. So if you just want to get a bunch of movies real quick, actually, probably response. I think it's results. Okay, cool. So here, just immediately, you can see that we have 20 movies like this. I think this one, these literally just came out. So great, awesome. This is just by searching through year equals 2021. If you look down here, you have a bunch of different query parameters. I just took year from here. So year of 2021. If you want to narrow it down to a specific year or range of years, you can just run this over and over again. Maybe I want to do release date. Maybe I want to look at language. I can do that too. Specific regions, ways that you can sort them. You can do whatever you want. In terms of pagination, because each query result only gave me 20, one thing you can do is use the page number to help you. And it does say that the maximum is 1,000. So I guess the maximum is 20,000 movies in this scenario. So from this result, again, all you have to do is clean up your table and get it in the format that you want, and you'll be good to go. I was talking about the genre IDs yesterday, I think, or the day before, I forget. I was talking about genre IDs. You can actually get the genre mapping from TMDB as well. So from here, if you look into genres, it basically just gives you the genres here. So let's figure out how this works together. So prior to that, I was doing tmdb.discover. So let's just see how it works. Is we do genre equals to tmdb. Was it genre or genres? Let's see. Okay, genre. All right, I guess that doesn't work. If that doesn't work, I think you might also be able to use this API directly. But basically, a lot of trial and error involved. I don't want to go through it right now. I want to leave this to those of you who want to figure it out for yourselves. Figure out how to get the genres if you'd like. If not, there's a manual to find it. I think the genre list is actually available online somewhere. So TMDB genre codes. I think that is somewhere there. Yeah, if you take a look, here are your genre codes. Feel free to use these manually if you'd like. But yeah, that's APIs. Wrappers are great. I think some of the main big APIs like TMDB has this TMDB simple wrapper. Spotify has a wrapper called Spotify for Python. Let's see what else. Yeah, if you ever wanted to get a bunch of data about your own music, about like your own like songs, about just songs in general, you can do that through Spotify's API. That's actually a really neat one. I think Rotten Tomatoes, actually, if you want to use Rotten Tomatoes, actually has a wrapper just like TMDB simple. I think they actually have it. Let's see, where is TMDB simple? I think if you scroll down, it says that, there we go. There's a Rotten Tomatoes one as well. I've never tried this one yet before, so maybe, I don't know how it works, but feel free to try if you'd like to take on the challenge. But yeah, hopefully this will help for those of you who want to find your own data that is maybe a little bit more up to date. See how this works. Again, I did not walk through any of the cleaning processes. That is for you to figure out. Parsing through like your JSON results and turning it into a data frame that is maybe more desirable than something that looks like this. That's up to you to figure out. But yeah, at this point, any questions? Awesome, great. Let's turn off the recording.